Hello, trigonometry, and welcome to part 2 of 8.5, vectors in the Cartesian plane. Before I get to the main thing, I just want to give you a review of SOHCAHTOA. So let's look at this quick bell ringer. Given the following right triangle, use SOHCAHTOA to find sine, cosine, and tangent. So, if you guys remember, anytime you have a right triangle, you can use SOHCAHTOA. And let's say we have this right triangle with the sides 5, 12, and 3. And if our angle is given right here, we can easily label the opposite adjacent hypotenuse. You know the 13 is obviously the hypotenuse. Here is the opposite side because it's opposite the angle we're looking at, which leaves the adjacent or the attached side to be number 5. So then off to the side, if you wanted to find sine, according to SOHCAHTOA, sine is opposite over hypotenuse, which the opposite is 12, hypotenuse is 13. Cosine is adjacent over hypotenuse, which in this case, adjacent is 5, hypotenuse 13. And last but not least, tangent, according to SOHCAHTOA, is opposite over adjacent. So opposite, adjacent, the opposite is 12, and the adjacent is 5. Again, that's just a review of SOHCAHTOA. And also, I also want to give you a quick review of inverses. So let's say, for example, you just found that tangent is equal to 12 over 5. So 12 over 5. And let's say I wanted to find what angle would make tangent equal to 12 over 5. Or in other words, I wanted to solve for the angle. To do that, you have to use your tangent inverse. So in other words, you would take tangent inverse of both sides. And on the left side, the regular tangent and tangent inverse would cancel. And that would just leave you with theta. Now we just have to do tangent inverse of 12 divided by 5. Or more specifically, we got to do arctangent of 12 over 5. And don't worry, arctangent is exactly the same thing as tangent inverse, just written differently. So let's see what arctangent of 12 over 5 would be in our calculator. So again, if you don't have a calculator, you can use this calculator on the website, eewab.com/tool/calculator. And this will be a calculator that will easily give you everything you need. So we wanted tangent inverse or arctangent, which is calculator. Arctangent is labeled as a tangent. So a tangent or arctangent of 12 divided by 5. 12 divided by 5. And then make sure your parentheses are closed and then press enter. And you'll get your angle, 67.38. And also make sure your calculator is set to degrees. You will need degrees for this lesson. So then you would say on the slide that the angle is equal to 67.38 degrees if you round it 2 decimal places. Please keep that in mind about how to get tangent inverse, because we will be using that in today's lesson. So now that we've had a nice bell ringer refresher on that, now let's move on to the main stuff for part 2 of this lesson. So just a little introduction. Let's say that you're a pilot and you're flying a plane. Let's say there's a wind that has velocity v and it's going in one direction. And let's say it's going towards the east. But you have a plane with a velocity u going in a different direction. In other words, it's going due north. Now, with these two vectors being forced at the same time, we would receive a third vector from the forces joining. Because let's be fair, if you're flying this plane due north and you have a wind that's pushing you due west, do you really think your plane is going to keep going perfectly north? Probably not. Chances are what's going to happen, your plane is going to keep forcing itself to go north. The wind, if it's a really strong wind, is going to push you somewhere to point in this direction. So in other words, the two forces working together will get you somewhere in the middle. Now mathematically, there is a way to calculate these two forces and see where the plane would be pointing. Let me show you on the next slide. So given the two vectors u and v, what would the third vector be like when those two forces work together? So to be specific, let's say the wind had a vector like this, where it was going 7 units to the right, but it didn't go up or down. It was perfectly going due east. Then let's say the plane had a velocity, or a vector, 0, 6. It's not going left or right, and it has a force of 6 going due north, or going upwards. Now, how would you actually combine these two forces? And it turns out, it's really as easy as adding them. For example, so let's say we wanted to take the force of the plane and then add it to the force of the wind. Literally adding them that's just it, you're adding them. But what you specifically add are the numbers within each spot. So in other words, these two numbers, 0 and 7, since they're both in the left-right spot, you would add those together. So 0 plus 7 to give you 7. And then the up-down parts, the numbers that are in the right side spots, you would add those together. 6 plus 0 to give you 6. And this is what would be the third vector. Or in other words, this is the actual direction your plane would be going. It would go 7 units this way, 6 units up, and it would be like that. That is where your plane would actually be going with the wind forcing it with its vector. And it's really as easy as that. Adding vectors, you just add the horizontal movements, you add the vertical movements, and you're done. Piece of cake. So now, let's just practice some other examples similar to this. And just so you know, there's actually going to be some multiplication involved too. So let's say I have these two vectors, u and v, and I want to calculate 3 things. I want to calculate 4 times v, then negative 3u times 8v, and then v minus u. I'm going to go ahead and do 4v first. So I'm going to do 4 times vector v. And it's literally just how it sounds. You're going to take vector 4, or no, you're going to take the number 4 and multiply it by vector v, where vector v is negative 6, 0. And the way that you're going to multiply it, you could probably guess that it's going to actually be... Oh, those are so annoying now. Why don't they turn them off? Okay. You are actually going to distribute. Literally just take the 4 and multiply it to each part in the vector. So for the first one, negative 6 times 4 will give you negative 24. Then negative 4 times 0 is going to be 0. Don't put 4. 4 is adding. You're multiplying. 4 times 0 is 0. So that's what you get when you do 4 times vector v. It's as easy as that. But now moving on to the second part. Let's say I have negative 3u, and they need to add that to 8v. So in other words, I'm first going to take negative 3 times vector u, where vector u is negative 10, 3. Then I'm going to add that to 8 times vector v. Vector v is negative 6, 0. All right. So, first things first, let's do the multiplication part and distribute. So that's going to get me for the first one, that's going to give me 30, and then negative 3 times 3 will give me negative 9. Then I'll multiply the 8. And that will give me 8 times negative 6 will be negative 48. And then 8 times 0, again, is just 0. All right, that's the multiplication part. Now all that's left is to add these together. So add the numbers in the first spots, 30 plus negative 48. That should give you negative 18. And then last but not least, add the numbers on the right side. So negative 9 and 0, that'll give you negative 9. And that's what you get when you do negative 3u plus 8v. Easy as that. All right, I think you guys got the hang of those two. I'm going to go ahead and erase the work so that I can have space for the third one. But now for the third one. This one I'm going to need you to pay close attention to. So the next one, v minus u, I have a lot of kids that will do this. They'll take the two vectors, subtract, and then they'll end up getting, say, -4, 3. Now, take a moment to look at that. I want to see if you can figure out what I did wrong. Hopefully you figured it out by now. But what I did wrong is this. This is vector u minus vector v. Here's the thing. The v was supposed to be in front, not the u. And of course, you guys know subtraction, order does matter. Because if you flip the order around, it will give you a different answer. That is a common mistake a lot of kids make. So you got to be careful. So let's go ahead and do that. We're going to do v first, u second. So vector v is going to be first. So -6, 0 minus vector u, -10, 3. All right, so now, again, subtraction is one of those that's really difficult for some kids. So first, let's do -6 minus -10. -6 minus -10. That's what we're going to do in the first one. The second one, we're going to do 0 minus 3. So 0 minus 3. Okay, now that we have that, notice here you got minus the negative, which will make that plus positive, which will give you +4. And then 0 minus 3 to give you -3. And that's what you get when you do v minus u. Piece of cake. So again, please be careful with subtraction. Do not rush it. And you should be able to get those just fine. So now, moving on to the next topic, I want to introduce you to unit vectors. Unit vectors are a special type of vector that are only 1 unit long. And there are two different types of unit vectors. There is unit vector I, which again, it's only 1 unit in length, but specifically it goes 1 unit to the right. As you see here, 1 unit right doesn't go up or down at all. That's the first unit vector. The second unit vector is vector j. Again, it's 1 unit long, but this time it doesn't go to the right, it goes up 1. It doesn't go left or right, but it just goes up 1 unit. So again, they're called unit vectors because they're only 1 unit long, and they're different because of the direction that they point in. This is actually notation that is used a lot, especially in advanced mathematics, like calculus and engineering. So with that said, let me show you how to translate these unit vectors with the notation. So let's say you're given this notation, 3i plus 7j. What's going on here is basically saying, for the first one, you're taking unit I. Hold on 1 minute. Okay, never mind. Someone's being really loud outside. I was going to ask them to be quiet, but we're good now. Anyway, moving on. What's going on here is basically saying it wants you to take the unit vector I, multiply it by 3, and of course you know the unit vector I is 1 unit to the right. And if you multiply that by 3, that means you're going to move 3 units to the right, which is what is translated here. And then for the second one, you know unit j is 1 unit up. If you multiply that by 7, 1 unit times 7 is 7 units up. So if you think of it that way, this notation, this notation actually just translates into your normal component form notation. Basically, take the 3 and take the 7, and those would be the numbers in your component form, 3 and 7. If you think of it that way, it actually makes it easy to understand what's going on here. But this notation is also very helpful when we need to draw some triangles, as I'll show you in the next slide. So, as I already showed you, 3i plus 7j, if you take the 3 and the 7, its component form would just be 3, 7. But let me show you how we can make a triangle out of this. So 3i, you know the I moves you to the right. The 3 will tell you, okay, I got to move 1, 2, 3 units to the right. So let that represent like 3i. And then, of course, the 7j, the j tells you to move 1 unit up, times the 7, that's 7 units up. So from here, let's go 7 units up. 1, 2, 3, 4, 5, 6, 7. That would be 7j. And of course, as you've seen, if we were to add these two vectors together, we would get the component vector 3, 7, which of course would just be this vector right here. That's 3, 7. And look at that, we now have ourselves a very nice triangle. And the reason why I showed you how to make a triangle out of all of this is because this triangle is actually going to be very helpful in helping us finding angles. Like for example, let's say I put an angle there, and sure enough, it turns out to be a right triangle. That means I have an opposite side, I have an adjacent side, and I have a hypotenuse side. And let's say, for example, well, the hypotenuse side, you don't really know what the side is because it's still just the component form. But you do know that the opposite and the adjacent are 7 and 3. And with opposite and adjacent, you know that you can use tangent. For tangent, again, is opposite over adjacent, which in this case, the opposite is 7 and the adjacent is 3. So in other words, you can use this information to help you find what that angle is. And you can use that angle using tangent inverse. And I will show you how to go through all that with an actual example. Now, before I move on to some actual Hawks examples, remember how to draw a triangle from the previous slide. And also, you'll need a refresher on how to find magnitude. We learned this in the previous video. Basically, if you need to find the magnitude, or how long your vector is going to be, you take the square root of a squared plus b squared, where the a and the b come from your component form vector. You're going to need to remember that. So now, with all that information tied in, now let's approach an actual example. So let's say in the Hawks program, you're given vector u is equal to 3i plus 7j. It says find the magnitude and direction angle of the following vector, and then write your angle in degrees rounded to 4 decimal places. So let's first start with the easy stuff. You know from the previous slide that the magnitude is a squared plus b squared. Now, you can't really use a and b until you have your component vector form. But if you remember, if you have the unit vector 3i plus 7j, just take the 3 and the 7, and that makes your component form. So therefore, you can use the 3 as your a and the 7 as your b. So let's go ahead and use that to find our magnitude. So we're going to have 3 squared and then plus b squared, which will be 7 squared. Go from there. 3 squared is 9, 7 squared is 49. And then just add those together, and you get that the magnitude will be the square root of 58. Now remember, if you're able to split these up into 2 perfect roots, please do so. And it turns out for this case, if you try all the perfect roots, square root of 1, square root of 4, square root of 9, square root of 16, etc., you'll find that nothing will work. So in other words, you will just keep your answer as the square root of 58. All right, that part was easy, just doing stuff from previous examples or from the previous slide. But now let's say we need to find the angle. So maybe to find this angle, I'm going to need to draw a triangle. So in other words, let's use the stuff that we talked about in the previous slide. 3i means 3 units to the right. So 3i. And then 7j, the j tells me to go up. And the 7 means I'll go up 7 units. And we know that 3i plus 7j is the same thing as the vector 3, 7. So let's draw that vector with the component form 3, 7. So there you go. You have a perfectly good triangle, and you can use that to help find the angle, specifically of this vector. We'll make this the opposite side. We'll make this the adjacent side. Well, this is technically the hypotenuse side, but we do not have the length of that side. Well, technically we do, but we don't really need it right now. We can easily find the angle that we're looking for by using the opposite and the adjacent. So let's do that. So again, opposite over adjacent, that means you can use tangent. So tangent of theta equals opposite over adjacent, which is 7 over 3. Continuing from there, we now have a perfectly good equation that we can solve for the angle. We just have to get rid of the tangent. And you guys know how to get rid of the tangent. You just got to take the tangent inverse. So tangent inverse of both sides. On the left side, the tangents will cancel, and you just get theta. We just have to do tangent inverse of 7 pi over 3. So let's go ahead and get our calculator, and let's do that. So tangent inverse will be the same thing as arctangent or a tangent. Make sure your calculator is in degrees, and then we're going to do 7 divided by 3. 7 divided by 3. Close parentheses, press enter. And you're going to get 66.8014. Because remember, the instruction said round to 4 decimal places. So we're going to do 8014 as our 4 decimal places. So then going back here, our angle will be 66.8014 degrees. And again, please put the degree symbol because we are in degrees. And that's all it is. That's how you do it for those examples. We'll do a couple more so you can get familiar with them, but that's basically all there is to it. So now let's try this example. Find the magnitude and direction angle of the following vector, angle in degrees, round to 4 decimal places. So let's first find the magnitude of u, which we know the formula is the square root of a squared plus b squared. Well, let's first find what a and b is. And of course, as you guys know, to find a and b, just take negative 11 and 12, and that's your component form, just like that. So in other words, the negative 11 is your a, and the 12 is your b. All right, let's go from there. Plug the a in, you'll get negative 11 squared. Plug in the b, and that'll give you 12 squared. Continue from there, negative 11 squared will give you 121. 12 squared will give you 144. Add all those together, and you will get that the magnitude of u is going to be the square root of 265. And I'm going to try and see if we can split this using a perfect root. And I will let you know I've tried. I tried using the square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, etc., etc. I couldn't find anything that worked. So in other words, 265 stays as it is. And that's your answer for the magnitude, just like that. Piece of cake. So now we got the magnitude. Now let's move on to the angle. So to help us with the angle, let's go ahead and draw our triangle. Let's go ahead and draw a triangle. All right, so first, we gotta do negative 11i. We know that the I is 1 unit to the right, but our 11 is negative. Ooh, that means we might have to go in the left direction this time. So in other words, we're going to have to go to the left, negative 11i. But then in terms of up and down, we got 12j. The 12 is positive, so that means we're still going to be going up. So let's go up 12 units, and that'll give us 12j. And then for the third part of the side, you just do negative 11, 12, which would be, again, 11 units to the left, 12 units up. So 11 units to the left, 12 units up. And that gives you the vector negative 11, 12. Done. All right, we got our triangle. And now that we have a triangle, we can now find the angle for this triangle, where this side is the opposite, this side is the adjacent, this side's the hypotenuse. So, we already have an opposite and adjacent, two easy sides. We can go ahead and use tangent for that. So, tangent of our angle, opposite over adjacent, which will be 12 over negative 11. Again, we'll be doing tangent inverse of both sides. So then that way, we can find what the angle is. On the left side, the tangents will cancel and you'll get theta. And then we, on the right, just have to do tangent inverse of 12 divided by negative 11. So let's go ahead and put that in the calculator. Clear tangent inverse of 12 divided by negative, make sure you use this, not the minus sign. Oops, a little too much. 12 divided by negative 11. Close parentheses and press enter. And we're going to get negative 47.4896. Round that to 4 decimal places. The 5 would tell me to round up. So that'd be negative 47.4896 degrees. And some of you are probably feeling a little uncomfortable because the angle's a negative. Ms. Shulin, something doesn't sound right about that. Are we supposed to get a negative angle? Are we? What, Ms. Shulin? Can you please explain? Well, let me tell you what's happening here. What's happening here is tangent inverse. Well, let's think about it. Where is this angle? Where is negative 47.4896 in terms of the graph? Well, as you guys know, negative angles go downwards from where we start at 0 degrees. So the angle negative 47.4896 would be somewhere around here. And that is nowhere near the angle that we need to be. Now, what's happening here is that tangent inverse can only be between negative 90 and 90 degrees. It cannot compute anything greater than 90 or less than negative 90. Which is what we need in order to be in the second quadrant. But this still comes to us an advantage because the angle that we found is actually the reflection of our actual angle. And what I mean by reflection is we found the angle, it's just we need to add 180 degrees to reflect it back to where it was. So in other words, you technically have the answer, just the reflected version of the angle. To find the angle we're actually looking for, you're going to have to add 180 degrees. And that will give you the actual angle That's in quadrant 2, not in quadrant 4. So let's go ahead and do that. We'll do 180 plus that angle. And you guys can go ahead and do this part. So 180, okay, hold up. So negative 47.4896. Go ahead and add that to 180 degrees. Enter. And you will get your actual answer for quadrant 2. 132.5104 degrees. And sure enough, as you guys know, 132 is definitely an angle that is in quadrant 2 because it's between 90 and 180. So there you go. That's the angle you're looking for. All right, let's try one more example similar to that, and then we'll move on. So one last time, we're given u vectors negative 12i minus 7j. We're going to find the magnitude and the angle. So again, the magnitude, square root of a squared plus b squared. And for the a and b, just rewrite vector u in its component form, which will be negative 12 and negative 7. All right, now that we got that, let the negative 12 be a, and let the negative 7 be the letter b. Now let's plug and chug. Plug in the a, you'll get negative 12 squared. Plug in the b, you'll get negative 7 squared. Take the square root. Negative 12 squared will be 144. Take the negative 7 squared, you'll get 49. Add all that together, and you'll get that the magnitude should be 193. And of course, see if you can split them up if you can. See if you can find a perfect root. And trust me, I've already tried. I got nothing. So we would keep that as it is. You get the absolute value of u, or not the absolute value, the magnitude of u is square root of 193. All right, moving on to the next step. We need to find the angle. So let's go ahead and find a triangle to help us out. First, I got to do negative 12i. That's going to tell me to move left or right. So that's going to tell me to move left, negative 12. So negative 12i. And then I got negative 7j. J is the unit to tell me to move up or down. Multiply that by negative 7. That's going to tell me to go down 7 units. So negative 7j. And then for the third part, you'll do negative 12, negative 7. So 12 units to the left, 7 units down, and that's your third vector. That's going to be negative 12, negative 7. All right, now you have a perfectly good triangle. We'll use this angle here that's in the origin, and we'll use that. Okay, so that makes a negative 7 the opposite. That makes a negative 12 the adjacent. And of course, the green side is the hypotenuse. We already have an opposite and adjacent, so we'll go ahead and use tangent. So tangent of our angle is the opposite, which is negative 7, divided by the adjacent, which is negative 12. Ooh, this is nice. Give me a sec. Negative 7 divided by negative 12. Negative divided by negative makes that plus positive. That's nice for us. Excuse me. Okay, moving on to the next step. We got to get the angle by itself. So we got to take tangent inverse of both sides. Tangent inverse, tangent inverse. Tangents cancel on this side. Now we just got to do tangent inverse of 7 over 12. Go ahead and do that. So tangent inverse. Erase that. All right, clear. Tangent inverse or arctangent, a tangent of 7 divided by 12. Enter. And that is our current angle, 30.2564 degrees. The fifth part is a 3. That means we don't round up. So let's go ahead and write that down. That we got 30.2564 30.2564 degrees. Now, real quick, where is that angle? 30.2564 degrees. Wouldn't that be somewhere in the first quadrant, like 30.2564 degrees? That would be in the first quadrant. But were we trying to find the first quadrant? No, we were trying to find the third quadrant. Tangent inverse just found the reflected answer. We need to find the actual answer reflected back by adding 180 degrees. So take your answer, add 180 degrees, and that will give you the angle that is in quadrant 3. Because quadrant 3 is the angle we want. So take your answer, add 180, and you will get 210.2654 degrees. So there you go. I think you guys got the hang of this. Pretty easy stuff. Now I just got 2 more examples to go through and we're done. And the next examples are going to be a little bit tricky, so brace yourselves. Now before we move on, I'm going to have to recall the formula to help you find the component form. So remember, let's say if you're trying to find the component form, like you want to find what number to goes left or right, up or down, etc., etc. This is the equation you use. You do the magnitude times cosine of the angle, and then for the second number, the magnitude times sine of theta. We're going to be using that in these upcoming examples. So just wanted to throw that out. We did do this in the first slide, or the first video. It's just a refresher. So now, this example gives us the magnitude, and it tells us that vector v is in the direction of 10I plus 6j. And it's telling us to find the component form of vector v, given its magnitude and the angle it makes with the positive x-axis. So more specifically, we'd be able to do this if it gave us the angle. Unfortunately, it does not give us the angle. And also, it's telling us specifically, or specifically it's not telling us to put our answer in degree, or our answer as a decimal. Specifically for this instructions, it does not say decimals. So in other words, we got to do an exact answer or put it in exact answer form. So, now remember, the instruction says to find the component form. Or in other words, we need to find this vector. And remember, the formula from the previous slide to find the component form is this. Absolute value of v times cosine, absolute value of v times sine. Now, we have the magnitude. The magnitude they give us is 14, so that's fine. But they don't give us an angle. They instead tell us that the vector is in this direction. More specifically, they don't want you to find an angle. They're going to want you to do SOHCAHTOA. So in other words, you're going to have to find cosine using adjacent over hypotenuse, and then you're going to have to find sine using opposite over hypotenuse, and then go from there. Which means we are going to need to have a triangle. So let's draw a triangle like we've been doing previously. All right, so let's see what we got. So first, we got unit I, which tells you to go right, and it's being times by 10. So that means we're going to have to move 10 units to the right. Then unit J is going to be telling you to move up, in this case, 6 units. So we're going to move up 6J. And then, of course, as you guys know, 10I plus 6J is just the component form 10, 6. So in other words, whoops, let me do that. So then the third side will be 10, 6. So remember, our objective, we need to find what sine is using opposite over hypotenuse, and we need to find what cosine is using opposite over hypotenuse, or adjacent over hypotenuse. That's what I meant to say. We have an opposite, we have an adjacent, we just don't have a hypotenuse. But you guys know how to find the third side of a triangle. You just have to use a squared plus b squared equals c squared, where c squared is the hypotenuse. And of course, you guys know, to find c, you're going to take the square root of both sides. So then to find c, you're going to take the square root of a squared plus b squared. I don't know about you guys, but doesn't that look like the formula to find the magnitude? Oh my God! You guys knew how to find magnitude this whole time. It's literally the Pythagorean theorem. Oh my God. And that just made my day. Well, I mean, I already knew that, but that probably made your day a little bit. But anyway, so you guys know how to find magnitude. You've known how to do it all along. You just had to do the Pythagorean theorem. So let's go ahead and do it. To find the hypotenuse, you got to do the square root of a squared plus b squared, where we'll let 6 be a and 10 be b. So 6 squared plus 10 squared. Go from there. That's going to give you 36 plus 100, which will give you the square root of 136. And then let's see if we can split this. 136. Can we split this? I think you can, actually. Let's see. 136 divided by 4. Yes, we can. We can use the perfect root of 4. Whoops. Because 4 times 34 ends up getting us 136. And of course, the square root of 4 is perfect root, so it goes down to 2, and then just 34. And unfortunately, 34, that's as simple as it gets. So then that is our hypotenuse, or our magnitude. So let's go ahead and do that. So let's let our hypotenuse be 2 square root 34. There we go. Now we have our triangle. We have all 3 sides. And let this be your angle, where this will be the opposite, this will be the adjacent, and then this is the hypotenuse. I'm going to go ahead and erase all this work here that we got for the hypotenuse, just to make room. Good? Good. Done. Awesome. Okay, so now we have everything we need to find the answer we're looking for. So again, I'm just going to write the component form formula down here. So to find the component form, I got to do the magnitude times cosine, and then the magnitude times sine. All right, so we're already given the magnitude of vector v, which is going to be 14. So we're going to have 14 here, and then 14 here. Now for cosine, we got to do adjacent over hypotenuse. The adjacent side is 10. And then the hypotenuse is 2 root 34. So hypotenuse on bottom, 2 root 34. That is cosine. And then over here, we got to take 14 times sine, or sine is going to be opposite over hypotenuse. The opposite is going to be 6. Hypotenuse, I'll go on bottom, is 2 root 34. Okay, now we have all the pieces we need to simplify. And yes, this is not going to look pretty. And no, we cannot write decimals. It's going to look a little disgusting, and that's okay. So I'm going to first do 14 times 10 over root 234. To multiply, I'll go ahead and write 14 as 14 over 1, and then I'll multiply horizontally. And that's going to give me, on top, 140. On bottom, I'm just going to have 2 root 34. Do the same thing on the other side. 14 over 1, multiply horizontally. 14 times 6 should give you 84. And then on bottom, you just get 2 root 34. And once you're there, you're technically 95% done. The last thing that you can do is simplify. And what I mean by simplify is that you still got 40 divided by 2, the two numbers outside the root. And 140 divided by 2 will give you 70 on top, 1 on bottom, but you don't need to write that 1 on bottom. And then over here, you can do 84 divided by 2, which should give you 42 on top, 1 on bottom, but you don't need to write the 1, so you just have 34. And once you're here, you're officially done. If it doesn't ask for decimal answers, that's how you're going to write your answer, just like that. It doesn't look pretty, but it is correct. Okay, so let's just do one more example where we do that stuff so you get comfortable, and then we'll be done for 8.5. So we need to find the component form again. So in other words, we got to use the component form formula. Magnitude times cosine, comma, magnitude times sine. We already know that the magnitude is going to be 9 of vector b. We just need to find cosine and sine using adjacent over hypotenuse and then opposite over hypotenuse. And we're going to have to draw a triangle to figure out how to do that. So let's go ahead and draw ourselves a triangle. And we're going to use 5i, 7j. So 5i, that tells me to move right. And we're going to move right 5 units. So 5i. And then the j tells you to go up or down. And the 7 is positive, which means we're going to go up 7. So 7j. And then all that's left is we need to find the hypotenuse. And of course, to find the hypotenuse, you can use a squared plus b squared equals c squared, where the c is the hypotenuse, which of course is the same thing as the square root of a squared plus b squared, which is just the magnitude. For the a, you can make that 5, and the b, you can make that 7. You guys know how to do that from there. I'll let you guys do that. But I will let you know, you will get that the hypotenuse will be the square root of 74. And trust me, I've tried to split 74. Sadly, 74 is as good as it gets. It does not simplify or reduce anymore. There's no perfect roots to help us do that. So, we now have all 3 sides of our triangle. And let's put our angle right here, which makes this the opposite. This is the adjacent, and this is the hypotenuse. All right, so we got everything we need. Let's get that formula back up. So to find the component form, absolute value, or not, magnitude times cosine, comma, magnitude times sine. We already know that the magnitude is 9. Now, we got first, we're going to multiply 9 by cosine, which is adjacent over hypotenuse. Adjacent is 5. The hypotenuse is root 74. All right, now the sine, where sine is opposite over hypotenuse. The opposite will be 7. Hypotenuse, root 74. Okay, you got everything you need. Now let's simplify. First, I'm going to do 9 divided by 1, multiply horizontally. That's going to give you V equals, well, 9 times 5 will give you 45. 1 times root 74 doesn't change. It's still root 74. I'm going to fix that. So square root of 74. Okay, now do the same thing for the second part. 9 divided by 1 helps us multiply across. 9 times 7 will give you 63. On bottom, you'll just get root 74. And you can't reduce anything from here because there's no 2 or 3 or 4 in the front to divide the 45 to 63. So this is as good as it gets. And this is the component form, written as exact as possible. No decimals, etc., etc. Okay, whew. That one was a biggie. That's probably going to be the trickiest one of the lesson. So please be careful on that one. Rewatch these examples if you need to. But besides that, you guys are ready to go. Go ahead and tackle that 8.5 homework online. And if you have questions, just email me.